All right, ladies and gentlemen, I'm recording today's lesson, which is 4.6, and we're going to talk about how to use CPCTC. I can't even spell acronyms, right? CPCTC. And this stands for corresponding parts of congruent triangles are congruent. What this means is if we have two triangles and they're congruent, all of their parts are congruent. Okay? Can I use this to prove two triangles are congruent to each other? Yes or no?
Yes.
No. I already have two congruent triangles. I can use it to say two of the sides are congruent, two of the angles are congruent, and so on, if I already know the triangles are congruent. This is very important. You should put it on your postulate and theorem sheet. Okay? You will be using it on the quiz tomorrow. CPCTC is very useful, very important. We're going to use it for the proofs today. You ready? Okay, again, can you use this to prove two triangles are congruent? No. We only use it to prove parts are congruent. Okay. All right. We've got 4 proofs. We might not do them all. We'll see how much time we have. We're going to look at, first, I've got a lot of overlapping triangles. So part of the problem is figuring out what triangles we're talking about, and then possibly separating them so we can see two triangles. Okay? So we're going to work on that, as well as using our new CPCTC. First thing we always write down is the given. The other thing that I would like you to write down besides the given is putting it on our picture. So RT is congruent to AS. So I go to RT. That's congruent to AS. Okay. And I've got RS is congruent to AT. So I go to RS is congruent to AT. Okay. All right. So what do you think? Should we separate these two things?
Yeah.
All right. We need to prove angles. So we're probably going to prove two triangles are congruent first, and then use CPCTC to prove the angles. Does that make sense? Okay. So we've got two triangles. So the two we're talking about are right here, with RST and STA. Okay. So first, we know that RS and TA are congruent. And we know, what else? We know RT, is congruent to SA. Okay. So, is there anything up there on that original picture that overlaps that when I separate it, so when I separate it, they should have the same letters? S does, but it's not the same angle for each of them. Oh. ST. ST is congruent to ST. I heard somebody say, oh, here's my question. When we separated the two triangles, is O up there? No. No, that's why. And we know ST is congruent to ST by what? Reflect that. Okay, so ST is congruent to ST. What do we know about these triangles now? How are they congruent? Let's do it. Congruent STR is congruent to triangle TSA. By what? Side, side, side. And Justin, what's a great way to tell? How did you tell that they were side, side, side? So I looked at the picture, and I saw that all 3 sides were congruent to all 3 sides. And remember, with all triangles, you need 3 things. So we know we're looking for side, 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 angle, 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 side. All right. But this is not what I'm trying to prove, right? Because right here under proof, it says angle TSA is congruent to angle STR. So I know this last one over here should be TSA, angle TSA is congruent to angle STR. But how do I know that? CPCTC, corresponding parts of congruent triangles are congruent. CPCTC. Okay, so let's go down to the next one. All right, the next one is a little more complicated. We've got PR is congruent to PR is congruent to PQ. Thank you, Emily. We know SR is congruent to TQ. So as I write them on my given, I'm going to mark it on the picture. PR congruent to PQ. So I walk over and, okay, PR, the whole thing, congruent to PQ, the whole thing. Okay, and then I've got SR is congruent to TQ. So SR, this part right here, congruent to TQ, this part right here. All right. You're right. I should write where given. Here's where it gets tricky. I want to say something about Q to S and R to T. So what triangles am I talking about? Because there's a lot of little triangles in this big triangle. TQ. Those are just two sides. That doesn't make a triangle. Okay. So I'm going to help you out with this one. Hopefully we won't get any too complicated like this for your homework for at home. We're going to use PQS, and we're going to use STQ. PTR. Okay. This is where it gets a little complicated. Does anybody see something up here that overlaps? Side or an angle, where when I separated the two triangles, it's the same letter, but they go right on top of each other and they're the same thing. P. So I know angle P is congruent to angle P, and what do we call that? Flexible. Didn't we just do this? No? Okay. Now, the tough part is these triangles look a little bit different. We've got one side, but then we don't really have the part of the other side. So we're going to use some segment addition to figure this out. I know that PS plus RS equals PR. And I know that PT plus TQ equals PQ. And we call that segment addition. Okay, what do we know about PR and PQ? So look at the given. What do we know about PR and PQ? PR is congruent to PQ. See, PR is right here. PR is right here, and PQ is right here. We're going to set the rest congruent to each other. What is that called? When I take something out and put something in? Substitution. Like a substitute teacher, Emily. Okay. Is there anything else here that I could substitute? Look at line 4. Is there anything else up here that's congruent? SR is congruent to? QTQ. Right, so I can take this out and put this in. PS plus TQ equals PT plus TQ. And again, we call this substitution. You might have one like this, so you should probably pay attention. Okay. So what can I do with TQ and TQ? I can subtract, right? Because they will disappear. And I get PS is congruent to PT by subtraction. This is all stuff we have done before. We did it in chapter 2. Okay, so now, ladies and gentlemen, if I go back to my separated triangles, I've got that these sides are congruent, I've got these sides are congruent, and I've got the angle is congruent. So what does that call for those triangles to be congruent? Side. Side, side, side. 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 Angle. Side. Okay. So triangle PTR is congruent to triangle PSQ by side, angle, side. Okay, but that's not what I wanted to prove, right? I wanted to prove Q. Yes. I want to prove QS is congruent to RT, so what can I use to prove that? Deflection. How is QS congruent to RT? We've proved that the triangles are congruent, so what are we going to use to prove that the sides are congruent? CPCTC. CPCTC. That's perfect. Okay. All right, let's turn it over. See if we can make it through all of these.
We could do 4 and not 3.
Let's try it. All right, let's do 4, and if we have enough time, we'll do 3. Because there's one closer to 4 on your quiz. Okay. We've got angle 1 is congruent to angle 2, so let's put it right here, and let's mark it. 1. Who's ever got the pen, please stop. Okay. We've got angle 5 and 6. We've got 5, and we've got 6. This is given. Okay. We are trying to get to AC is perpendicular to BD. Alright? So, we're going to have to prove 2 sets of triangles are congruent to each other. And then we can get there. So the first thing I'm going to look at is there anything up here that is on top of each other that I can use reflexive for? C. C is not an angle. We have angle 5 and angle 6. C is the angle for the kite, but we're looking at triangles. What is overlapping that we could use for 2 triangles? A to
C.
C. There we go.
C.
AC is congruent to AC. You guys got to start being able to see those, or we're going to have some hard times with these proofs.
How do you even get that? How do you even know that? AC is the same line.
It's the same line.
I'm just saying, like, normally you would be like, you can't prove that or something.
No. If they touch each other like that, you can always prove that.
So if they touch each other, they can prove it.
As long as one's not like hanging off to the side. Yeah. Okay. All right. So here's my question. Do I have a triangle that's congruent to a triangle?
Yes.
Why? So I've got angle, and then side, and then
Angle.
so triangle ABC is congruent to triangle ADC by angle, side, angle. Okay. All right. Now that I've proved the 2 big triangles are congruent to each other, What I want to do is prove that these smaller ones are congruent.